For this demo, my sprite batch manager is going to have 3 groups of 4 sprites each. Group 1 is going to be birds, group 2 is going to be stitch and boxes, and 3 is going to be aliens. Looking into this function, for example, my sprite batch manager operates on an object called sprite batch. Quickly show on sprite batch, which is a subclass of D-Link and has a priority number and a sprite group manager. Sprite group manager operates on sprite group members, which is a subclass of D-Link and has references to already existing sprite classes. So when we call add batch with priority, we're going to grab a new node off the reserve list, set it up with our priority number, and then we insert it into sorted order into our sprite batch manager, sorted on our priority numbers. When we call add member to batch, we're going to add our member into the appropriate batch, our node into the appropriate batch, and we're going to just put it onto the front of our list since we don't care about what order these nodes will be inside our batches. So the lower the priority number, the sooner that batch will be affected within this sprite batch. Our bird batch will get affected first, then our boxes, then our aliens. So when we run this, we're going to see that the birds are drawn first because they had the highest priority. Then our sprite boxes will be drawn on top of that, and then our aliens will be drawn on top of the boxes. If we switch our priority numbers around, we'll switch the order in which things get affected. So now our birds will happen last and our aliens will happen first. And when we run this, we will see that our aliens are drawn first this time, then our boxes and stitch, and then our birds are drawn on top of that because we reverse our priority numbers. We can also change the batch priority numbers during runtime. For update sprite batch with new priority method, we basically decide if the node to move is either going to move forward or backwards in the list. Regardless of which direction it goes, we're always going to be swapping it with the adjacent node. And the swap function I defined as in the base class manager basically just swaps the links between two D-links. And we're just going to keep swapping adjacent nodes until the node we changed is back into its final position. I have an example set up here where first we're going to render our birds first and our aliens last. Birds first and aliens last will be rendered, and then after some time we'll switch it so our birds will be rendered last and our aliens will be rendered first, and then after some time again we'll switch it back to birds first and aliens last. And now when we run our demo, we're going to see it alternate between birds first and aliens last and birds first, with our stitch and boxes remaining in between the two. And for the extra credit, when we have a sprite batch manager, we can handle different kinds of concrete sprites. When we have a sprite group member, it takes in a sprite base reference, and our sprite base reference is an abstract class that inherits from D-Link, and it has a couple of abstract methods that we have to implement. From that, we have a concrete sprite class which handles the concrete azul sprite object, and we also have a concrete sprite box class which handles our concrete azul sprite box object. And for this demo, our group 2 had a mix between the two concrete classes. We have a sprite class for stitch and 3 sprite boxes, the red, yellow, and green, and these were all added into our group 2 batch, which we were able to render.